Hello everyone, if you made it this far, tutorial 3, we're up to ECS Post Insertion configuration. There is an issue with this checklist, and you can see here that we're supposed to be running a secondary accumulator leak check. So we're going to flip ECS indicators to secondary, and we are going to take a look at our accumulator, which is under 50. So we will need to fill our secondary accumulator. Here's primary fill. That's actually good. The issue with this checklist is you could see that here is the primary glycol to radiator bypass, but we could see in the actual checklist, it's glycol to radiator secondary and secondary accumulator quantity. So it doesn't make sense that we would be messing with the primary bypass if we're doing a secondary accumulator check. So let's do the actual procedure then. Glycol to radiators secondary normal for 30 seconds. And we're basically checking to see if this level falls. If it falls, we have a problem. If not, we're good. And after 30 seconds, we can go ahead and we can switch that off. So that just allows flow to the radiators. It's a very basic procedure. Here we have the circuit breaker, which will activate the post-landing vent. And we could see that this is tied to the flight bus and the post-landing bus. Post-landing vent's located behind this bracket, which is supposed to be able to fold away, because obviously you don't want all this crap in your way when you're doing landing and stuff. But that vent basically allows you to recirculate air between the outside and the inside. It's used after splashdown. And the reason it's used is because normally to equalize the pressure, you would use the cabin pressure relief system. However, when you're splashed down, if you use these systems, you'll actually take in a mass amount of water just because the actual ports for those are, towards the bottom. So you would use the vent, which is towards the top, so that you don't suck in water. Speaking of which, cabin pressure relief valves, or the cabin valves, during dump, it basically fully opens the valve, and it lets all the pressure out. During boost and entry, it allows the valve to close and open all the way to maintain a 5 psi difference between the outside and the inside. If you were to have these all the way to close, you would basically run the risk of exploding the capsule due to pressure, because as you're rising, the difference between the outside and the inside increases. The inside containing 16 psi on launch, and now you've essentially got the equivalent of not 16 or not 5 psi, right? Because the outside's 12, the inside is like 16 to 18, so that's 5 psi pressure on the walls. Now you've got essentially 16 psi difference pressure on the walls of the hull, and you may explode. So these need to be set to normal. If you set these to dump, you will vent your cabin out to space. Adios, poof, bye-bye, gone. So please do not set those to dump. Push them to norm like this. If you close it, that maintains the valve in the manual close position. So if you overpressurize the cabin through the direct O2 flow or through the emergency repress system, you can explode. So normal is like an automatic maintaining 5 psi difference. All right, so that's this position. Not this position, not this position, not this position, this position. Normal and normal. Another thing to note is that clicking this check mark does not automatically do a step for you. Okay, common misconception. Primary glycol evaporator out temp should be 38 degrees. We could see primary glycol evaporator out temp is not 38 to 43 degrees. So set temp in here to auto. And actually, no, I lied. It's not going to show that until after we start radiator flow, obviously. That's actually wrong. Yeah, in reentry, this is not simulated properly. The evaporator is able to run independent of your radiators. The evaporator is evaporative cooling, and it's supposed to be used in place of the radiators. When you're in orbit of the Earth or the Moon, you have a lot of time in the sun, and then a lot of time in the shade. So you would use the glycol evaporator to make up for that fact. When you're doing passive thermal control, you can shut the system down and just run off of radiators. But we'll come back to that. We are going to stop using the glycol reservoir. So first you open the bypass, then you close the outlet, and then you close the inlet. And this basically, the reservoir is a giant tank of glycol, and we bypass everything, and we switch it off. So we keep that tank, but whatever is in the loop is now just going to continuously run in the loop. It won't be dumped into the tank and then taken out of the tank. It will just run through the loop continuously. Now we verify our primary accumulator is 25 to 50%. That's good. Primary accumulator valve to on. Again, this is not true. Because we're above 50%, it says monitor MDC to fill until 50%. We're above 50%, so we turn it off now. The checklist doesn't tell you to turn it off. You need to know that. So it's important you know that what these systems are. So please pay attention to my explanations. The accumulator takes glycol and pumps it in to the line. So here we could see our accumulator is 50% filled. That allows us to basically run up the evaporator, which will eat into this accumulator level a little bit. If we run up the coolant loops, it'll eat into that level. It'll dip down as the pump spins up. And so that's why we want to have a little bit in the accumulator. If there's nothing in the accumulator, then the lines are only recirculating what are in the lines. And when you run the pump, you run the potential of forming a void in the line. Because you have increased the discharge pressure, the suction pressure has to increase. And if there is just enough fluid to maintain the fill level, the discharge will happen and the suction will happen, and then the flow hasn't gone around all the way just yet, right? It takes time for the flow to go through, and so the suction will form a void, and then you'll suck a void into the pump, and you'll be pumping nothing, basically. The glycol acts as lubrication for the pump as well, so you can severely damage the pump. So it's always important to keep the accumulator filled up. Radiator flow control. There we go. If we power that up, that allows the basically the grandfather to the programmable logic controller to control when to send glycol to the radiators and how much of it to send. And now we can start, bam, radiator flow, and we can see temperatures and everything are normal. Now this was supposed to dip the this was supposed to increase the outlet temperature and dip the inlet temperature. The primary glycol evaporator was not supposed to be affected by that. It seems that they have it backwards for now. So it's just something you have to deal with, but radiator heating to on. Just because if the glycol gets cold, you know, we don't want to freeze up those radiators. So it's very important that, you know, we've got some heaters for that. And it says to monitor glycol primary out and in temp for 5 minutes. So we're just going to do a little bit of time skipping, and we could see, whoop, everything's coming up. And we're basically at our operating set point. Outlet temperature should be greater than the inlet temperature after 5 minutes. If it's not, which we can see it is actually struggling to come up a little bit. If it's not, what you'll do is you'll pull the bypass, and then you'll wait 10 minutes. And that's going to allow, it's going to allow the glycol to heat up a little bit, and then you'll run it again. We'll turn on our drinking water supply. That's fairly obvious as to what that does. We'll need the heater for that so that we don't ice the tank when it gets cold. And of course, we'll need the in temperature to be automatic on the evaporator, and that'll keep it at its proper temperature. We'll need to begin heating up our wastewater tank and our urine tanks as well, so we don't ice those over. And those switches were graciously already set to on, so we just plug in the circuit breakers. And then we're going to need to isolate the repressurization package and then begin filling it. If we lose cabin pressure faster than the emergency O2 pressurization system and the main regulators can support, we also have the repress package, which will pump in pressure really, really quickly into the cabin, faster than your pressurization controls down there. Once that's in the green, you can go ahead and then turn it off and isolate that package again. And that is your ECS system. So I'll just go ahead and just explain sort of the rest of it. So we got primary and secondary as determined by these switches. You can see the needles that move have a secondary value. So it's this one, this one, this one, this one, and this one. They all have a primary and a secondary. Inlet to the radiators measures basically how much heat is being produced by the spacecraft and how much load the radiators are taking. Outlet will tell you how efficiently the radiators are operating. I'll give you the temperature of what's directly after the radiators. This measures actually your primary outlet, and here measures your secondary outlet. So you don't even need to switch this knob to see that. The glycol evaporator, as we discussed, here is the outlet temperature, so you can see how efficiently the evaporator is running. Here's the steam pressure. If we're not evaporating, steam pressure will be pegged. So if we completely shut this thing down, this should bump up to 0.2. And that would mean that we're not running the evaporator, which of course, since we are in Earth orbit, we should be running. We have the pressure, the glycol discharge pressure. That's the pressure after the pump. So the pump has a suction pressure, it sucks in, and then it discharges out. and that discharge is what we're measuring. We can see the flow. If we were to shut down this pump, you can see we lose the discharge pressure. It's not that fast in real life, but the effect is the same there. So good job, reentry. Actually, all of this is wrong except for that. Suit compressor, yeah, that just gives you the proper differential between the cabin and the suit loops that is required. The suit compressor will compress oxygen into the suit loop, and it should be maintained slightly above or equal to the cabin pressure. And then the accumulator, of course, as we discussed, that is basically, you could think of it like a shock absorber for the glycol loop. When you run up the pump, you should see a small dip in that. And then the H2O, that measures your potable water or your wastewater. And your wastewater is used as feed water for the glycol evaporator, and your potable water is used as drinking water. You've got your radiator systems, and that's pretty obvious. So radiators will just output heat as infrared radiation, as light. And you've got your heater for it. You've got your flow controller, and flow controller will, tell you which radiator to go to. It'll tell you how much flow and whatnot. You've got the primary, and you've also got a secondary flow controller. You can manually select which radiator to go to, radiator 1 or radiator 2. And we can see radiator 1 is currently very hot, whereas radiator 2 is currently very cold. And off will basically, I think, just keep it flowing through both. But we can see with it on in power or automatic mode, basically, it'll automatically tell us which automatically select which radiator it needs to go to. As we said, potable water heater keeps the water from freezing. We've got the suit circuit H2O accumulator, which is a moisture separator, and that will pull water out from the air, and that will put it in the waste tank. It's very important because if you have this turned off, water will accumulate in the actual suit loop, and it will prevent oxygen from being added. Then we've got the heat exchanger, which should be left in off because in the coolant control attenuation panel, we've got the heat exchanger set to flow, and it should never be taken off of flow, so that's in flow and disengaged. So this switch you really are never going to touch. And then you've got your secondary coolant loop. This is the evaporator pump and the evaporator system. It's basically a copy of the primary, but a little bit simplified. There's not the flow control and the temp control. It will always run at 100% the rated speed. And then, of course, you can adjust the cabin temperature. And here you've got readouts for your temperatures, pressures, and your partial pressure of CO2 measured in millimeters of mercury. And that is your environmental control system. So next up will be the tutorial for systems check, which is a whole ton of stuff that you technically don't need to do because sims are perfect. However, I'll walk you through them anyways. So, see you next time.